today we have number of substrings containing all three characters, and it's a problem where it states that there's a string S that has characters A, B, C. It wants the number of substrings that have at least one occurrence of all the characters A, B, C. So speaking in an example like this, we can have at most, or something like this to be clearer, it wants a substring where it has A, B, C. So if we start from here, we gotta get the C and the B in the same substring to be able to consider this as a substring, right? And the way to look at something like this is obviously you could do this with the double loop iteration, where you could start at every index and count the number of substrings you find both B and C in as well, but that's not pretty efficient and probably will give you a time limit exceeded. This is a sliding window problem, a typical sliding window problem, where you would have a window, but it's a variation of the sliding window because you do not have a fixed window. So there's the sliding window problems can be like, there's two ways of having sliding window problems. The sliding window problems with a fixed size K, and the sliding window problems where the fixed size is actually a condition. It's not like, it doesn't give you a fixed size. It's actually a condition that if it breaks, the sliding window moves, right? Instead of having some sliding window of a fixed size where you move it, no, this one is not a fixed size. This one is dynamic. It's like flexibly sized, but it moves according to conditions. That's what control it. So what does that mean? In a question like this one, you could see something like, okay, so here the only way to actually get a substring is to go to the end, right? And when I go to the end, that is considered a substring, but isn't also this considered a substring, and isn't also this considered a substring? Yes. So the window will move. The window activates when it finds what it wants. What does it want? It wants the S has A, B, C at least once. That's when the window activates. Then it starts to move. If the condition keeps being correct, we need a way to actually get all of the substrings that match the condition, because we could have a lot of duplicates, right? And we only need one occurrence. So the way to do something like this is we're obviously gonna keep a counter of all the occurrences of A, B, and C, right? Normally. And then what happens is, when we reach a condition where, okay, we found them all, right? We found them all. When we find them all, if there was a rest to this substring, so if there was some strings to the right side of B, that means we're gonna take them all anyways. We're gonna take every single character would make a new substring essentially. That means that right side next to the achieved part. So this made us achieve what we want, right? Anything to the right is a bonus. So anything to the right basically counts as a substring because we've already found what we wanted, right? And what that means is, so basically that's a variation. Taking one right side to B is a variation, taking two right side to B is a variation, etc., 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 right? And then also, when we look at the left side, we gotta keep decreasing from the left side till the condition breaks. So also looking at the left side, we gotta keep decreasing. So we gotta keep decreasing from here, decreasing till it goes A, C, B. That's like the base one. That's like only has 3 characters, and then it goes CB, right? So CB basically cannot work. So it has to keep going to the right side. So it starts discovering again and builds new substrings, etc., etc., etc. So this is the cases here where we have a sliding window. We move the pointer R, right? We keep incrementing in our counter, right? And then while we find the length of count equal 3, which is, we have ABC now, we're gonna increment. We're gonna add to res the difference between B and the length of the whole string, right? So this is the right side essentially. We're gonna add the right side to res because that means that number of substrings exists already without moving any left pointers, right? And then we're gonna start moving the left pointer. We're gonna start decrementing our left pointer moving it to the left side, and if it goes down to 0, then we delete it from counts. And then every time we move to the left, if this condition is still the same, we're gonna actually keep adding length of s minus r, because for example this, alongside with every part of the other of the right side, still is a substring, different substrings, and so on and so forth, right? Till we return the final res. So time complexity wise, this is O of n, and count is really like constant on at this point because you only have 3 characters. Yeah, hopefully you guys enjoyed this. See you in the next one. Thank you guys for watching.